Everyone, sorry about the delay. I'm not sure my Zoom crashed, and so I had to restart it. But how are y'all doing?
Doing good.
Good. Well, we got a full group today. All right. Must be the day before test. Yes. Must be. Okay. All right. So we have a few things, administrative things to take care of first. You know, on Thursday, we're going to be coming in here just like this. Everyone's going to have to get their camera set up properly. And I'll be emailing you the test. You'll be either printing it or copying it down. And then you'll be taking the test on camera. And then the big thing is at the end. When you finish, you're supposed to send me all of your handwritten work as a single PDF file. So I said that I would take a little bit of time to answer any questions on that, but I was also hoping that you would have taken some time after last class to take it upon yourself to do that. Were there any issues? Any questions that you might have on how to do that? Or no one came to my office hours for help, so.
So I think I figured it out. I want to verify with you. I just sent you an email with my review in a single PDF form. Did you get that?
I can check.
Because that would that would verify that I actually got it right.
Yeah, I mean, I can check. I don't want to do this for every single student, you know, because this will take me too long, but I can check yours and it'll maybe be a good example. Hopefully, Hunter, it's a good example.
If nothing else, it'll be an example of what not to do.
Yeah, exactly. Okay, so let's see here. Let's see what Hunter sent me. Now, you sent it through Canvas or no?
Yeah, just the normal little messaging thing.
Okay. There we go. So let's see what we got here. Yeah, 11 pages in a single file. That's exactly what I'm looking for.
Sweet.
Yep. And I know some of you also uploaded the review to the Dropbox, right? So let's see the quiz. So I've had 20 people submit the quiz. Let's see if anyone did multiple files. Olivia.
Yeah, I tried. I got I have the Adobe.
Sorry, this is exactly why I want a single file.
Yeah, I tried. I used Adobe Scan. I had it on I did it on my phone. I was trying to do it on my computer to see if I could get that file down to one. I guess it just didn't work.
Yeah. So, I mean, it's just,
I don't know how to.
Maybe I won't have as much time after class today, but
Okay.
I don't know, maybe during my office hours tomorrow or maybe later this evening. If you're around, just shoot me a text and then I can maybe jump on Zoom and help you, but. Okay.
Quick question. Should I upload mine to that Dropbox? Because I completely spaced on the fact that we're supposed to.
Yeah, you should upload it to the Dropbox.
Cool.
Yeah, because this is where I'm going to go to grade stuff. Okay. So are there any questions about the way the exam is going to take place? Camera setup? Anything like that? You're gonna either print or hand copy the test, right? Unfortunately, that's the only thing we can do. And then you'll send me a chat, you'll say, hey, I'm starting, and then you start. You take test. You can only have your formula sheets and blank paper, and then the printed exam or handwritten exam. That's all you can have. You'll show the camera all your papers, every single one of them, both sides. And that way I know what's in front of you. And then, you know, you begin the test. When you're done, you will send me a chat saying I'm done. And then I'm going to give you like 10 minutes, maybe 15 minutes to upload the exam to me. So from the time you send me a chat saying I'm done, you'll have, let's say 10 minutes, okay? But I'll probably give a 10 to 15 minute window there. for you to be able to get it all into one file and send it to me. If it's late, I can't accept it because obviously in fairness to the other students in the class, you send it in an hour after you finished it, and then I don't really know what you did for that hour, right? So, yeah. So it's all clear?
Yes, sir.
Does anybody want to show me their camera, the way it's like, ask me if this is like certain particular angle is okay? Because pretty much there's nobody here right now that has a camera set up properly. Like everyone's going to have to move their camera. And you can use your smartphone for your camera if you want. Just make sure you have a charger nearby so it doesn't die during the test.
I'm probably going to end up having to sit in a different room because my computer desk is not sufficient to put something to record and also have room to write.
Yeah. I'm looking for something like my camera, you know, where you can see the whole space. It's really kind of what I'm looking for. I don't need like right zoomed in on you. Okay. I just need to see what's around you.
Also,
go ahead.
How do I get to that Dropbox?
Check your email. When I sent the quiz or somewhere after I sent something, here's the link for it. It's in there somewhere.
I'd spaced on that. Sorry.
It's all right.
Also, when are you planning on grading the reviews?
Oh, it's not high on my priority list right now. They'll get done. I wouldn't expect them before the test.
Okay.
Yeah, but they'll get done. Their quiz grades, they'll get in there.
So how long is it going to take to, like, you know, print out the actual exam and then we have to show you our work? I feel like that's going to take, like, you know, kind of a lot amount of time. Is that?
Well, you don't have to wait on everyone else. Okay. So as soon as I email you the test, if you have a printer, then you print it and you start. If you don't have a printer, you're going to have to handwrite the test, which, you know, everyone's going to handwrite at different speeds, right? So I'm hoping no longer than 15 minutes to get everyone going. It's the first test, so it's always going to take a little longer because there's going to be someone who can't get their camera set up properly, and I don't know, maybe it'll work okay, but everyone will be on their own. So like Ethan, if you write it down, you're like, I'm ready to go, you start. Any other questions?
Yeah, I sent the exam review through the inbox too.
Through Canvas inbox?
Yes.
Yeah, you need to send it through the Dropbox.
Okay.
Yeah.
Thank you.
And I had the exam I had you send it to the Dropbox, the review. The exam, I think I'm going to use OneDrive instead. It's the same thing. It's going to give you a place to upload your work, but just so you know, I may not be using Dropbox. I might be using OneDrive. You'll get an email that will have a link. You click on it, you'll upload your work. Yes. What?
Someone asked in the chat if you're going to upload the answers to the review.
Well, first I need to go see if I have the answers pre-made. That would really be good if I do. If I don't, I'll try and get them out. I'm not going to promise today, but I'll try and get them out. Don't count on them, but I'll try and get them out as soon as I can. That was what, fall 2018? Is that what that test was? I'll look for it later. Tell you what, I'll go this far. I'll set a reminder. How about that?
I have one more question. You mentioned using our phone to record. Can we just use our laptop and set it kind of far away?
For what? For your camera?
Yeah.
Oh yeah, that's fine. Yep, you can use your camera off your laptop, move it around. Really, the only camera issues are if you can't like set your laptop up around you. I mean, again, I'm expecting the test is in 48 hours. So if that means you need to figure out, like, go get a little table from the other room to like set it up on, you know, like practice this. Don't come in first time on Thursday being like, oh, I can't, I can't set up my camera, because two things will happen. First of all, you're going to irritate your classmates because they're going to hear us talking. They're trying to take a test. And then the other thing is you're just going to lose time. Solutions, anything else? No? Okay, let's get going. So we have new material to cover today, but it will not be on the test. If it's on the test, it would only appear in the form of a bonus question. All right. Now that doesn't mean tune out and not pay attention and sit there and go, oh, I'll figure this out later. This is a really important day because we're starting chapter 2. All right. And I told all of you when we covered continuity is a weird section. It's it gives me a headache whenever we go over it. I really didn't like the way I felt after class last time. It's just ugh. But chapter 2, section 1, this is where the good stuff starts happening. So let's get into this. Today's the 14th, right? Thought I had this made already. Okay, I have lots of notes to cover. These notes are available in Canvas in a PDF form. So again, don't worry about copying this all down. You have access to this. What you don't have access to is the actual animations, but you can go back and watch the video. At least you'll have the text and stuff is all available to you. Okay, so we are starting chapter 2, which is called derivatives. And if you were to ask a Calculus 2 student, like, what's Cal 1 about? They'll say derivatives. Like, that's basically, we've reached the kind of the main idea of this course, which is this idea of this thing called the derivative. So the first section in this chapter is called derivatives and rates of change. Then we move on, derivative as a function, basic formulas, different rules. And then we get to 2.7's the monster. This is the section everyone hates. It's word problems, okay? But we're still quite a bit away from that at this point. So 2.1, this is very visual. What we're about to do is very visual, but there's going to be some things that we're going to rely on from college algebra. And as we go through this, I will remind you of the things from college algebra that we need here. Now, I'm not going to go into an in-depth review of it, but I will at least gloss over it again. Okay, so you can all read this, but it's important, I think, for me to go through this. We've been talking about limits, right? The majority of what the previous section was limits. And what happens if we see 0 over 0 or infinity over infinity or fixed over 0 or fixed over infinity or all these different combinations, right? But at the end of the day, it's just we were investigating limits. So now what we're going to do is look at one specific limit, a very, very special limit that is going to allow us to just take off and go in this really crazy direction and be able to solve a lot of problems. Going back to a picture that I gave you all the first day where we're trying to find some slope of some line on some function. That's exactly what today is about. So, but keep in mind, we're looking at one specific type of limit, and this thing is eventually going to be called the derivative. Okay, so everything is motivated by the idea of the tangent problem. Okay, so if I were to give you a circle, then let's say I start with some point on the circle, and then I get a second point on the circle, and I draw a line connecting these two together, right? This is known as a secant line. Secant line. That's what it's called. A line that connects 2 points on the circle is called a secant line. Now, if we take the blue point and start to move it around the circle towards the black point, of course, the line is going to change, right? And if I'm able to put the 2 points right on top of one another, then we get a very special line called the tangent line, right? So the property of this tangent line is, well, on a circle, the property is that it touches the circle just at the edge. At one point, it's touching the circle. And if you were to connect a line from the center to the point here, the radius, okay, this would be a radius line. This would come into that tangent line at a 90-degree angle, right? So that is the property of a tangent line on a circle, Y'all seen that before, tangent line to a circle? Hits the circle at one point, yeah? All right, so what we're gonna do now is step away from the circle, because in the classes that we're dealing with, right, in the classes that we've dealt with in the past, everything we've ever looked at has been a function, which means that it's passed the vertical line test, right? A circle does not pass the vertical line test, so this is not a function. So, but the idea of a tangent is kind of established from this picture. So now let's look at a general function, okay? So here's some general function. We all agree this passes the vertical line test. Again, let's take some arbitrary point on that function, just like we did with this black point. Let's just take some black point here. And then let's see if we can't first talk about the secant line. So let's pick a second point. I'll move it over here. There we go. We have a second point here in blue, and the line connecting these two is a secant line. Now, if I start to slide this point along the curve, just like I slid it along the circle, I'm going to get closer and closer and closer to that black point, and just watch the pitch of this line. It's going to move around and move around, but eventually it starts to tilt up. And let me zoom in a little bit here. As I get a little bit closer, you can kind of see here that it's heading to something, right? I mean, like, it's obviously the pitch of this line is positive, right? We know that much. It's a positive pitch, positive slope. But see, if we take the point and put it right on top of the other one, now turn it green, that's the tangent line. It's the line that punches through that graph at a single point. The thing that we don't have here is we don't have the idea of like a circle with the radius coming out at a 90-degree angle. We don't have that anymore because this is not a circle. But we all need to understand that there is, through any point on this curve, there is one and only one tangent line possible. Like you couldn't sit here and say, oh, well, that's a tangent line that goes through that point, but here's another one. Like, that's obviously not tangent, is it? To that, at that blue point, that's not tangent. So we're trying to see, is there a way we can find this line? Go with me? We talked about this in the beginning, so I know it's not brand new information. So how are we going to do this? How are we going to figure out what this line is? Someone gives us some arbitrary point. Can we determine this line? Well, let's do the same. Let's review something we do know about lines from college algebra. And that is, if someone gives you 2 points, you can always find the equation of the line through those 2 points. So this, again, is something you should know from college algebra. If I start with a point, so notice I'm not talking about function anymore, just if we have a flat sheet of paper, we take 2 points, okay? Then we can always find the equation of the line that goes through those two if we figure out what the rise is and the run, and then we can come up with the equation. Now, the way we do that, okay, the actual way we do that is we use formulas. First of all, m, which stands for the slope of the line, is always your rise over run, which is always the change in the y coordinate divided by the change in the x coordinate. That little triangle it stands for delta, and delta represents change. So this right here is our change in y, and this right here is our change in x, better known as rise and run. Okay, that's the way we've said it in the past, but we're going to call it change in y over change in x. Now, technically speaking, it's the difference of the y coordinates over the difference of the x coordinates. That should look familiar to you. If we're given 2 points, x1, y1 is the first point, x2, y2 is the second point, then the slope is just y2 minus y1 over x2 minus x1. That gives you the slope of the line. Then to find the equation, what we do is we use this very important formula from college algebra. We're going to use this formula a lot in here, okay? This is called the point slope formula. And what this allows you to do is come up with the equation of a line so long as you have two things: a point, any point on the line, and the slope of the line. So you have to know this. This is the slope. And then the x1, y1 is any point. So this is any point on the line. And the slope obviously is the slope of the line. In other words, if I tell you, hey, I've got this line that goes through this point, okay? And then I say, and the slope of the line is 4. You should be able to generate the equation of the line for me, right? Let's try it for this one. Let's do it for this particular example, all right? For this particular example, I have my first point here, right? That's my x1, y1. My second point here, x2, y2. Let's figure out what the slope is. So the slope would be the rise, which is the difference in the y coordinates. So I take -4. I subtract from that the other y coordinate 2. I divide that by this x coordinate 5 minus the other x coordinate, which is -1. And then I just be a little careful with my signs here. I'm going to get -6 on top. And on the bottom, I get 5 plus 1, which is 6. So the slope of this should be -1. Okay, that is the slope of this line. That all look familiar to you? Now, once I have that, I can now come up with the equation of the line. I'm going to have to do this on the left here. The equation of this line, I used my formula, y minus y1 equals m times x minus x1. And so I just plug things in, right? So y minus, now which point do I use? Do I use this first point or the second point, or does it matter? Will we get different answers if I plug in one point versus the other?
It shouldn't matter.
It should not matter, which is kind of weird when you think about it, that we plug this in for x1, y1, we're gonna get the same answers if we plug this one in. It works though. Let's use this one first. So I'm gonna do y minus what? I'm using this point. 2, okay, equals m. M was our slope. We said that was -1. And then x minus what?
-1.
-1, this x coordinate right there. Let me clean it up. Y minus 2 equals -1 times x plus 1. I'll distribute my -1 through, and I'll add 2 to both sides. That is the equation of the
I have a
line
quick question.
that connects those points. Yes, go ahead.
So this is basically how to figure out that one equation, which is y is equal to mx plus b,
Y
right?
plus b.
Or is that different?
Well, what you're referring to is what's called the slope intercept form of the line. You're referring
Okay.
to this formula, y equals mx plus b. That's a different formula. This is the formula we use. It's called the slope intercept formula. So that's the formula you would use if you wanted to come up with the equation of a line. If I give you the slope and one very special point, the y-intercept. So if I give you the point in the y-intercept, then you're going to use that formula. If I give you the slope and some arbitrary point on the line, then you have to use this formula. Does that make sense or no?
Yes, sir. Thank you.
Good question. Hey, do y'all want me to check real quick that you get the same answer if you plug in the other point? I can do it really fast. Okay, let's do
Sure.
it right here.
Okay.
Y minus -4 equals the slope, which was -1, and then x minus 5. If I do that, I get y plus 4 equals -1 times x minus 5. I should have distributed that. Let me do that. -x plus 5. And now if I bring the 4 to the other side by subtracting it, I'll get y equals -x plus 1. Same answer. Okay, so as long as the point you're giving me is on the line and the slope is the correct slope of that line, then you can always generate the equation. Okay? Y'all good? Let me say it one more time, because this is so important, because I get students that forget this and they're like, what? How am I supposed to do that? If you have a point on a line and you have the slope of the line, you can find the equation of the line, right? That's the moral of the story here. All right, we move on. We're building up to this now. So let's take this specific example, okay? And what I'd like for us to do is see if we can't come up with the equation of a line connecting 2 points on this function. So the first point I want us to do, and by the way, the function here, if you can't read it, is the function f of x equals 3x cubed minus 5x. So what I'd like for us to do is take this first point, and it is the point I've already told you it's at -1 right here. So if I wanted to know what that point was on this function to figure out the ordered pair, plug in -1. Now look, this -1, I'm just picking it out of the blue. Okay, it's not special in any way. I decided I'm going to pick this point at -1, and then to figure out the y coordinate, we have to plug that into the function, don't we? So let me plug -1 into the function. That's just the function up there. We plug in -1, 3 times -1 cubed minus 5 times -1, and I would hope that you could get 2 there. So that gives you 2. So that's 1 point on this function, right? I'm going to pick a second random point now. Here we go. I decided to pick the point where we're going to plug in. We're going to plug in 1 for x. And let's figure out what this ordered pair is. Now, I've already given it away down here, but I want to make sure you understand what I'm doing. So I'm plugging in 1 into the function. And when we do that, we should get -2. So this has the point 1, -2, right? Now, let's find the equation of the line that connects those two together, right? Well, this is just the same thing we just did, right? Now the function actually doesn't even matter. I have 2 points, right? So I just want to find the equation. So I'm going to just set this up. I'm going to find the slope first. The slope is going to be y2 minus y1 over x2 minus x1. So I'm gonna treat this second one. The second point here is x2 y2. The first one, this is my x1 y1. So I'm going to take -2 and subtract 2. And then I'm going to divide that by 1 and take away -1. Careful with your signs there. None of this turns out to be 0. So -4 on top, and then on the bottom we get +2. So divide, you get -2. The slope is -2. So I have a slope, right, of the line I'm looking for. What's the one other thing I need?
Any point.
Any point, right? And I actually have 2 of them. So it's up to me. I get to choose. I don't care which one I use. They both give you the same answer. So I don't know. I'm just going to take that one. That's the point I'm going to use right there. And now I just come in here with my formula. Y minus y1 equals m times x minus x1. And that gives me y minus, okay, now y1 is 2 equals m, the slope, which we just found, which is -2. And then x minus, careful here, x minus -1. So I turn this into a +1, and then I distributed the -2 through. I think we just get y equals -2x. There it is. That's the equation of the line. It's the equation of the line that goes through those 2 points. The only thing special about those 2 points is that they happen to live on a function. Other than that, they're just 2 arbitrary points, right? We still good? So if we go back, we think about what we were trying to do here. We were trying to figure out what happens if we have 2 arbitrary points like this. We can find the equation of that line, right? We can find the slope and the equation. If I know these 2 points on this function. What we want to do is see if we can't move that second point closer and closer to the black point, eventually right on top of it, and get that equation of that line, right? So let's do that by first doing something where things are not as concrete. Here I gave you a specific function, right? And we came up with the equation line. Let's do it arbitrarily. What I mean is I'm not going to tell you what the function is, and I'm not even going to tell you the exact points I'm plugging in. Let's see if we can come up with a generic formula that would work for any function in any 2 points. Let me go through it. You'll see what I mean. So what I'm going to do is I'm just going to say here that I have some arbitrary function here. Okay, that is the function f. I'm not going to tell you what it is. And now what I'm going to do is I'm going to pick some arbitrary point on that function. Boom, there it is. Now, the only thing I'm going to say to you is that I am picking some value here of x, and I'm going to call that a. Right now, it could be a positive number, could be a negative number, but a is just some point on the x-axis. I would like to know what the ordered pair is here, right? So a is the x coordinate. The y coordinate is what I get after I plug a into the function, right? I've got to take that a and plug it in the function. Now, I don't know what the function is, so just symbolically, it's f of a right here, right? Then I take a second point, let's say right here. And again, I'm not going to tell you what this point is. So let's call this point, this x coordinate, let's call it b. Or sorry, x. We want to do something different. Sorry, let's call it x. I could have called it anything I wanted to. I'm calling it x. You'll see why in a second. Now, if I plug that in to our function, the ordered pair is going to be, well, the x coordinate is just x, and the y coordinate is what I get when I plug that x into the function, which again, I don't know what it is because I don't know the function. Do y'all see what I'm doing is I'm creating like a generic concept here. So let's figure out what the slope is. Well, the slope of that line will be equal to y2 minus y1 over x2 minus x1. And I don't know, I'll just call this one x1, y1, and I'll call this one x2, y2. And let's just plug into the formula. So somebody tell me what this is going to be.
F of x minus f of a over x
Okay,
minus
hold
a.
on. Slow down. So f of x minus f of a. So you're subtracting the 2 y coordinates, right? y2 minus y1 over
X minus a.
x minus a. There we go. Y'all got that? Does everyone agree that that is the slope of the line that connects these 2 points together? Good. Let's go a little further. Could you actually give me the equation of this line? Anyone? If I told you, look, use this formula again. There's the generic formula, right, for the equation of a line. Can we plug things in here and get a generic formula? So let's try it. Y minus, well, what's Y1 for us?
F of A.
F of A. Okay, so Y minus F of A equals M. Do we know what M is?
It's
No.
F of X minus F of A.
F of A over X
over,
minus
yeah.
A.
Yeah, it's that big ugly blue thing, right? That's M. That's M. That's this. And that's sitting in front of times X minus X1. So that's X minus, what's X1 for us?
A.
Hey, there it is. This is the equation of the secant line through those 2 points.
What would happen if you tried to solve that one further? Would you get anywhere, or would it just be
No,
worse?
because so Maddie, if I gave you 2 points, okay, let's say I gave you 2 points, all right, and a function. Okay, so let's say I handed you a function. I said, here it is, Maddie, here's the function, and here are the 2 points. If I did that, then everything in red you would be able to replace with a number. That would become 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 a number. So basically you would have like Y minus a number equals a number in front of X minus a number. And that's basically Y equals MX plus B. So you have the exact line. There's nothing that we would need to solve anymore because we're not trying to solve for X or do anything here. Does that make sense, Maddie? You're about to see why we did this generic formula in just a second, all right? Because you might be saying, why do this? Like you have, if someone gives you a function like the previous example, right? We did it, we got the answer, we got the actual equation, we're happy. So why do it generally like this? Why do it arbitrary? Go ahead.
Sir, why would you use X for X2? Because then when you use the generic equation at the end, the X minus A looks almost like X2 minus X1 when really that X is supposed to be the variable in general, not X2. Is there a specific reason
Wait,
you
say
used
again?
X? I get you used X for X2 for the generic equation.
Yes.
But in the actual form for the slope intercept, it uses X regardless.
Yes.
So did you do that specifically? Because it seems like it could be easy to confuse with X2.
Yeah, no, that you're bringing up a very good question. I kind of slid it by everyone. You know how in this formula, for X1, Y1, I told you could actually use either one of the points, right?
Yeah.
Because I showed it to you earlier that if you had 2 different points, you could use either one, you're going to get the same equation, right? You get the same equation.
Well,
What
you're gonna
Josh
do
is
X
bringing
minus
up,
X.
pardon me?
Yeah, isn't that gonna give you like an X minus X or something like that?
Yeah, so watch, what Josh is bringing up is that why, I use this point, right? When I use this formula, I did X1 right there is A, and I did Y1 is F of A. What Josh has kind of noticed is that, well, I could have done this one also. I don't know if this is what you're pointing out, but let's say we tried to do this point in here into this formula for the Y1, and instead of the Y1 X1, let's use Y2 X2. It would have become Y minus, well, what's Y2? Y minus F of X, right? Equals. Okay, what would this is all still the same thing. F of X minus F of A over X minus A. But this part right here would become what? X minus
X.
X. Okay, so what would you wind up getting here? That's a 0, isn't it? And it
Yeah.
kills everything off over here. And so at the end, you wind up with Y minus F of X equals 0. which means that y, if I move the f of x to the other side, equals f of x, which is true. That is true. Y is the original function. So what happens there is that you wind up with a true statement, but it gives you no information at all. It gives you zero information. It's not incorrect, but it just doesn't tell you anything. Where with this will give you the equation of the line.
Question.
Yes.
Would it occur similarly if you canceled out the x minus a being multiplied by the x minus a? Because if I'm remembering correctly, I think I
Yes.
can cancel this.
Yeah, if you cancel these, right? If you cancel these, then
Yeah, then you could cancel out your f of a and your f of a, and
move things around. Yeah.
okay.
But the point here for us is that what we are most interested in right now, okay, what we are most interested in is this, okay, this right here, because that is the slope of the secant line. I'm going to subscript the m with an SEC. This formula is the slope of the secant line. That is what is the most important thing to us right now. This formula, we'll get to it, all right? I just wanted to follow the same format of what we had done in the previous example. Get the 2 points, figure out the slope. Okay, what's the equation? Okay, here it is. Now that we know that, we have a general formula. If we pick 2 arbitrary points on a function, a and f of a, and x and f of x, then we have 2 major results. First, the slope of the secant line is this. Okay, we just said that, right? I wrote it down. And the equation of the line through those 2 points, the equation of the secant line is this. Yes? Okay. Now, how do we get the tangent line from this? So let's look at it geometrically. We've already discussed it. If I have my 2 arbitrary points, I draw the secant line. The way I can get the tangent line is by moving the second point closer and closer to the other point, and then eventually right on top. Right on top. We have a problem. So what's the problem we have if we put the 2 points right on top of one another?
Our point slope formula, the slope formula will get a 0 on bottom.
Yeah.
And
so
on top,
here,
you get 0.
here's the
0.
problem. Exactly. If the 2 points, x1 and y, x1, y1, x2, y2, if they get on top of one another, then they're the same exact point, right? So now what happens is when you try and do the slope of the secant line, you're going to get f of a minus f of a on top and a minus a on the bottom. And that's 0 over 0, which is undefined, right? It's undefined. 0 over 0 is undefined. That's the problem of putting the 2 points on top of each other, right?
Should we take the limit of that then?
Exactly. What's the workaround? Well, we've been faced with 0, 0 already, right, in this class? And we had a way of getting around it. What we did is we applied a limit, right? We took a limit and we asked ourselves, what's happening as this gets closer to this, right? Let's let this go to something and see what happens. Well, geometrically, if I bring this point back over here, remember, think about the x coordinates. This was a, right? And this was x. If I want to start moving my second point over, look at what x is doing. Where's the x now? The x is now, instead of here, it's now moved over to here, right? And as I keep sliding this over, right? Let's say I'm here now. Where's the x gone? It's gone from here. It's slid over, it's slid over, it's slid over, it's slid over. Here's where it is now, right? So where is that x headed?
Towards
Where's
A.
this x value headed? It's headed to A, isn't it?
Mhm.
Do I ever want it to get there though?
No.
Don't want it to get there, but I want it to get arbitrarily close to it, don't I? So that is dictating what I'm going to set up in the limit. I know that in order for this to work, I have to take a limit and I need that x to head towards A, right? Let X head to A. Now, what is it that I'm interested in? I'm interested in what happens to the slope, right? What happens to the slope when I do that? Well, what's the formula for the slope? Right? That's the formula for the slope. Right? This right here is the slope of the secant line. And I want to know, the question is, what happens to this? If I let the 2 points land on each other, I can't do that. So I'm going to let the X approach A, and that should tell me what's happening here. Now just check it for yourself. If you let X, remember when we do any limit, the first thing you do is always just substitute in, right? Just plug in. So if I replace the X's with A's here, A, we get what? F of A minus F of A over A minus A, we get 0 over 0, which we would say in a limit, what would we say? That's what?
Doesn't exist.
In a limit though.
It means it needs an
Undefined.
algebra
Problem.
trick.
You need algebra or a
yeah.
trick. See, if I tell you to just plug 0 in, you get 0 over 0, which is undefined. But in a limit, if we get 0 over 0, so this right here is headed to F of A minus F of A over A minus A, which is headed towards 0 over 0. And this is where we in the past have said, oh, this is bad. We need some algebra or some trick, right? And then we went to town, right? And we started doing something. That's exactly what we're about to do. We're going to say, hey, let's use the limit, all right? So let me continue with the notes. So we already said that if you move the 2 points on top of one another, then the slope of the secant line becomes undefined. But because we have the limit, we can now say, let's take the limit of that, right? Let's take the limit. This is the slope of the secant line. Let's take this limit, and whatever that limit is, if we get an answer, that will be the slope of the tangent line. That will be the slope. So the only difference between the formula for the slope of the secant line, here's the formula for the slope of the secant line. This is the formula right here. We've already established this today. That's the formula for the slope of the secant line. The only difference between that formula and the formula for the slope of a tangent line is that you take a limit of it and you let X go to A. It's the same exact formula, but you're just going to do a limit. Okay, so that's the only difference. It's not here, right? Not here. It's not there in the formula for the secant line, but it is here for the formula for a tangent line. All right, are y'all ready to do an example? I think it's time. Here we go. I would like for us to find the slope of the tangent line of f of x equals x squared plus x at a equals 2. Find the slope of the tangent line of that. And then after that, find the equation of the tangent line same problem. Okay, so it's all the same problem. So in the first part, I just want you to find the slope of the tangent line. Once you have the slope, then I want you to find the equation of the tangent line. With me?
So we plug A into X.
Let's just set it up. Let's take it slow. All right. First thing we want to do is find the slope of the tangent line, right? So what does that mean? We want the slope of the tangent line, right? That's what we want. The definition of the slope of the tangent line that we just established is always the limit as x approaches a of f of x minus f of a all over x minus a. That is the definition of the slope of the tangent line right there. But see, we actually know what a is here, right? They told us what a is. A is what?
2.
2. Now, Maddie, I don't know if that's what you were saying. Plug in, is that what you're saying? Just plug in 2 for a? I'm not sure if that's what you were saying. So for this particular problem, I'm going to take the limit as x approaches a is 2. So x approaches 2 of f of x minus f of 2 over x minus 2. So all I did here was replaced every a in the generic definition with the a for this particular problem, right? Is it clear to everyone right now that if I try and plug 2 in for x, I'm going to get f of 2 minus f of 2 over 2 minus 2, and that's going to be 0 over 0? Okay, but I'm not done. I actually know what f is, right? We've been given the function. So I should be able to figure out, well, I know what f of x is, don't I? Just that's the original function. And I should be able to plug 2 into the function also. So let's continue using this formula. This is going to be limit x approaches 2. Okay, f of x. What is f of x?
X squared plus x.
X squared plus x. Okay, minus subtraction here, f of 2. So maybe we can do this in our head. F of 2 is what we get when we plug 2 into this.
6.
6. So 2 squared plus 2, that should be 6. So we have minus 6 over x minus 2. Now check that for yourself. If you'd like, try that limit now, and you're going to get 0 over 0.
Just to be clear, you just plug the a equals 2 into f of x, correct?
I plugged the what?
The a equals 2 into the f of x.
Yeah, this right here, f of 2 just meant take 2 and plug it into this function.
That's
And
what
that's
I
how
was
we got to
asking
6.
earlier.
Yeah, that's what you were saying earlier?
Yeah.
Yes. Okay, so we get 0 over 0, right? When we take this limit, okay, this is bad. Algebra time. Does anybody see the algebra? It's easy.
Yeah, we factor the top.
Factor the top.
I have a question.
Yes.
How did we get x to the power of 2 plus x?
What was the function, right? This here in purple. What was the actual function? What is f of x? It was given to us, right? That was given to us in the problem, wasn't it?
Okay.
See, so before what I was doing was giving you a general formula. Now what we're doing is using that formula for a specific function at a specific point.
Mhm. And how did we get -6?
So you're subtracting from that, right? So this formula says plug in this, that's this, minus. Now this 6 should be this, right? F of 2. So what does f of 2 mean?
I don't know.
So if I ask you, hey, here's a function, what's f of 2? What am I asking you to do?
X to the power of 2 plus x.
Yes, but I'm telling you f of 2, not f of x. So I'm asking you to plug 2 into this function, right?
Okay.
So 2 squared is 4, plus 2 is 6, right? So there's your minus 6,
Okay, thank you.
right? So I heard factor, right? So I factor the top. That's what, x plus 3x minus 2 over x minus 2. These factors cancel. And remember when we talked about this when we were first doing these, that there's like a little asterisk, you have to promise me now that x is never 2, right? Well, it's not because it's a limit, right? We're letting x approach 2. So what's happening here is that this is now the limit as x approaches 2 of x plus 3, which is 5.
So our slope is 5.
Our slope at that point is 5. Okay, we've answered the first part. Now we need the equation of the line. Okay, so now for the equation of the line, I need to use this formula, y minus y1 equals m times x minus x1. Sorry, this is the equation of the tangent line. That's what the second part was asking for, right? The equation of tangent line. Well, I'm still going to use this generic formula from college algebra. Do we know the slope?
Yeah, it's 5.
Yes.
5. We just did that. Okay. Do we know a point on the
Yeah.
line?
Yes.
2 and
How?
6. 2,6.
Yeah. So I never explicitly gave you a point, did I? But I told you we we're supposed to do this at a equals 2. So if you think about this visually, it's like we're going to 2 and it's spitting out some value right here. It's 2 something, right? That would be a point on my function. And we already know what happens when we plug in 2. We got 6, right? So 2, 6 is a point. So to do this, I use the fact that the slope is 5 and that the actual point x1, y1, I can use that 0.26. And then you're back in college algebra, right? You're just going to plug in y minus 6 equals 5 times x minus 2. Y minus 6 equals 5x minus 10. Add 6 to both sides. There we go.
Question. I'm still kind of confused. Where did you get the 6 from?
Okay. This is the original function, right, everyone? The original function is f of x. This is the function I've given you, right? If I ask you to plug 2 into this function, you're going to take 2 and square it and add 2. This is 4 plus 2, and that is 6. Right? So here's what I know. This graph, if you were to graph this function, if you plug 2 in, it spits out a 0.6. Now, the rest of the function, I don't know what it looks like, but I can tell you that if you plug in 2, you get 6. Is that clear, everyone? Now,
I got
I
it.
would like for us to appreciate what we've just done. All right, so I'm going to show you something visually. The original graph here was x squared plus x, right? There's the graph of x squared plus x. We were asked to go to a equals 2, which corresponds to that point on the function. It's the 0.26, right? That blue dot. What we just came up with is the line that goes through that point that is tangent to this graph. And we said it was what? 2x, what was it? Or 5x, sorry, 5x minus 4? What was it? 5x, I forgot.
Yeah, 5x
Yeah,
minus 4.
5x minus
5 minus 4.
One thing, I was just looking at it again. Are you sure
Yeah.
it's not 5x minus 16?
What did I do?
Yeah. No, never mind. Never mind.
Hold on, something ain't right though.
I messed up.
Yeah, okay, you ready? I think we're good. You ready?
I sat there and
I'm gonna
looked over
graph.
it and did some math wrong.
Okay, I'm gonna graph 5x minus 4, okay? Here it comes. The line y equals, here's 5x, okay? It's 5x. I'm not done. I need to subtract 4. There it is. See that? That line punches right through that point, and I hope it's obvious to you that that line is tangent to the curve. You believe it?
Yeah.
Yeah. So let me try something a little different. Just a thought experiment here. Let's say you are a person walking along this function, all right? That's a little stick man, walking along this function. As I walk from left to right, I will be going down here, won't I? Down, 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 and then eventually I come back over here and I start going up, 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 right? And I keep going up, yes? Okay, you can tell that from the picture what's happening, right? You can tell from the picture what's happening. I gave you this function f of x equals x squared plus 4. And here's the graph of it. Now, if I take the graph away, and I say to you, hey, look, see this function? Go to that point 26, okay? If you were a man walking, or a woman, or whoever, whatever you are, if you were walking on that curve right there from left to right, your next step, is it up or down?
Up.
How do you know?
The 5x.
The 5. Do you remember the slope was 5?
Yeah.
The slope was 5. That tells you that your next step should be up, shouldn't it?
'Cause it's
And
5 over
5
1.
is pretty steep. If the answer was 2, it wouldn't be as steep. If it was 1, it'd be less steep. If it was 100, it'd be really steep. Does that make sense? So that being able to get that number 5 is very important to understanding the behavior of the graph without needing to see any of the picture at all. Was there a question? I thought I heard someone. What if I told you that at that point, I went and found the tangent line and the slope was 0? What would that make you think?
That you had that you
We're at
were
the tip of the parabola.
The what? That you're what?
We're at the tip, the vertex of the parabola.
Okay, so yeah, that maybe that would make sense, that if we were at the top of a parabola, then the tangent line would be running flat, wouldn't it?
or your
Yeah.
original formula is flat at that point.
Or maybe it's just a constant function, right?
Yeah.
So maybe you're at the top of the hill. Maybe you're at the bottom of a valley. Maybe your function was flat to begin with. Or maybe it was something crazy like this, where the function does that, and you're right here. Right? There's a couple of different scenarios that can happen. What I'm trying to get you to see is that us being able to get that number 5 is going to be so important to us being able to understand how to find the highest and lowest points on graphs. You have to go back and think about when I first introduced this whole idea to you in the very beginning. I gave you a problem where we were trying to lay fiber optic cable between 2 buildings. And I said, what we need to do is come up with the cost function. And then I said, we're going to do something to it. But basically what we want to know is where this cost is the lowest it can be, which means we need to look at the graph and find that bottom valley. Well, here's what I can tell you, that I need to find that point where when we find the tangent line, it's 0, because that will correspond to that point. So we're slowly building to this, all right? I don't want to get ahead of ourselves. Let's just do another example. Can we do that? So same instructions as the previous problem, same instructions. I want us to find, where's my cursor? Where the hell did it go? I'm going to give you a different function and a different point. Just trying to decide how bad we want to go right now. Let's go a little bad, but not too bad. Negative 3x cubed plus 2x. And I want this at a equals, let's go with the negative number, -2. That is a cubed up here, not a squared. All right. Everybody have it written down? Sorry, everyone have it written down? Okay, I'm going to show this to you visually first, okay? I'm going to show this to you visually first. So visually what we're doing is we're taking, I've already forgotten what it was, negative 3x cubed oh shit, I already forgot, sorry. Just focusing on some plus 2x. So we're looking at this graph, okay? And we're going to -2. -2. So I need to plug -2 into the function. Crap, what do we get when we plug in -2? We should get 20. So I want us to be looking at this graph. So all I'm doing right now is showing you visually what we're doing. We're looking at this graph, we're going to that point, and we're trying to find the slope of the tangent line there and the equation of the tangent line. Visually, that's what we're doing. So let's try it. What do we start with? What do we start with?
The slope.
The equation for the slope of the tangent line with the limit
Yep, which is
as x is approaching
limit
a.
x approaches a of, just give me the definition.
F of x minus f of a over x minus a.
Yes. So there's an old movie. I don't know. It's not too old. Kill Bill. Have y'all seen Kill Bill? Kill Bill 2.
Yeah.
If you haven't seen it, you haven't seen it. But there's a scene in Kill Bill where the main character is training out in the mountains with this guy, like training kung fu and all this stuff. And she's training so hard that she's waking up in the middle of the night, like punching into the air because she's like training. That's all she's doing. This limit right here is so important that it would be nice if you woke up in the middle of the night and were just saying it in your sleep almost, you know? Limit x approaches a, f of x minus f of a over x minus a.
But didn't she end up punching the wall and hurting her hand?
Yeah, she hurt her hand, yeah. So
Can't hurt your hand by waking up saying this in the night.
yeah,
No, but I can explode my brain.
Unless maybe your significant other gets irritated and decides to hurt you. But I guess my point is this: that definition you need to know. I mean, that is like at the core of what chapter 2 and almost all of Cal 1 is about, is that limit. Remember, I started today saying that we've been studying limits, practicing how to do limits, but there's a very special limit, a very special one that's going to allow us to do a lot. And that is exactly what you're looking at right there. That limit is the one that I've been referring to, this one right here. It is the slope of the tangent line. You have to understand, you have to appreciate what it took to get here. Like before this, 0 over 0 was just undefined. Isaac Newton figured out a way around it, okay? That was the huge leap. That was the huge leap that Isaac Newton was able to come up with. And, you know, it was not just Newton, it was the other gentleman who came up with calculus, Leibniz. We'll talk more about them later, but I just don't want us to lose sight of the fact that it took, you know, humans a long time to figure out how to get around the 0 over 0. And for us, it's that limit right there. Okay, here we go. Well, what's that?
Are we gonna go over integrals in this class too?
At the very end, we will do integrals or antiderivatives. Yes. We're just gonna put our toes in the water. We're not gonna get serious with it.
That's Cal 2, isn't it?
Yeah, that's really Cal 2. Okay, so right now all I'm gonna do is replace all the A's with -2, right? So I'm just gonna rewrite the formula. everywhere I've seen a, I replace it with -2. Everything that has an x stays an x. And then the next step is to actually figure out what this piece is and what this piece is. So f of x, that should be the easy one.
Yes,
Just f of
3x
x
cubed
is
plus
the original.
2a.
Yeah, it's just the original function, right? Just stick it in there and move on your merry way.
We did already solve the other one. It's 20.
Yeah, minus this f of -2, but people asked about this earlier, so I just want to be clear. When we're in this, getting this f of -2 right here, we are plugging -2 in for all these x's and just evaluating the function at -2. -2 cubed is -8. -8 times -3 is +20. Sorry, what is that?
Yeah, it's positive 24.
+24, and then you have 2 times -2, which is -4. So you have 24, take away 4 is 20. That step right there is not a calculus step. That's an algebra step, right? Just plugging a number into a function. So -20 is
It's been the hardest thing we've done all day.
Yeah. And then over x plus 2, be careful on the bottom. All right. Y'all okay with this? All right. So now we're going to crank up the heat here on you a little bit. All right. Let's just check what happens if we plug in -2 into this limit. What should happen? What should happen?
0 over 0.
We should get 0 over 0 because it's us putting these two dots right on top of one another. We know we're going to get 0 over 0, but let's just verify it. Yeah, we know up there we're going to get 20 minus 20. So yeah, we get 0 over 0. Okay, so this is bad. All right, we need some algebra or some trick, right? Okay, what algebra do we have? Uh-oh. Shoot, right? If that were quadratic, we'd be like, oh, we just factor it, right? It's not quadratic though. Let's do a little 3-minute Jeopardy. See if you can think through how to do that. And then I'll ask.
Long division.
Long division.
Complete the square.
Yeah. Why don't you everyone think for a moment? You gotta go back into the cracks of your memory in college algebra on how would you factor something like this? How could you try and factor it? Let's go. 2 minutes, 3 minutes, maybe. Feel free to talk to each other if you want. You can throw ideas out there. I'm just not going to respond. As you're pondering, a little background noise here. I would hope that you would agree that what we've done here is nothing crazy as far as just plugging things into a formula. What is now presenting an issue is the algebra. And I told you in the beginning of this class that the concepts of calculus are not necessarily the difficulty. It's the algebra within the calculus that gets tough. And that's what we're looking at here.
Yeah, I don't think it's factorable. Anyone debate me on that? Not in a standard normal factoring.
Everything is
And
factorable.
I don't think I don't think you complete the square on this because it's not quadratic.
Yeah.
Right?
There's also
Yeah,
not a difference
quadratic.
of cubes on it. The gut reaction with a cube is different to cube, but this isn't that either.
Okay. I'm going to call a timeout. Let's go back to something you know how to factor. I hope. I hope we all agree that this could be written like this, right? And we don't necessarily need any special factoring technique to do that. But I will remind you about something called synthetic division. And the way it works,
I forgot about that.
yeah, the way it works is that you look at the coefficients of the polynomial. Oh, sorry, that's not a 1, that's a 6. You look at the coefficients, and what you do is you set up this upside down box and you put in here 1, -1, -6. And then you start putting these numbers over here, okay? And what you're hoping for is a remainder of 0 to come out. Does this sound familiar at all?
Unfortunately, so.
Yeah, I remember this.
I was thinking of that was gonna work, but I forgot what it was called.
Yeah, I was like, I forgot.
I remember that there was
long
something
division
like
was
this,
it.
but I couldn't remember how to do it.
Now, long division would have worked, Ethan, but this is shorter, okay?
I meant to
look,
say this one too. I just forgot there's like, I forgot
Yeah.
there's 2 different ones. We used it. We did it right back to back with these things.
Yeah.
How did we do How did we do
Charles-
this again? Because I legit don't remember how to do synthetic division.
Charles,
too long.
-3 times -8 is +24. Yeah, okay, I think you got it. All right, so back to this. The trouble with this thing called synthetic division is that, again, you're trying to do this synthetic division and you're hoping to get a 0 here. And you have to come up with numbers to put here to do the synthetic division. And the way you come up with those numbers is you create a list of numbers to try. And it's a real pain in the ass because you have to look at all the factors of 6 and all the factors of 1 and create all the plus or minus lists. That may or may not ring a bell. What's important though is that if you do know one of the factors, like we kind of know this, don't we? We know that these are both factors. That means if I use the actual number that makes this 0, if I use 3 out here, I promise you I'm going to get a 0 at the end. Watch. See if you remember how to do synthetic division. You bring the 1 down. You do 1 times 3, you put that here, 3. You add down, you get 2. 3 times 2 multiplies up to be 6. You add down, you get 0, and you go, yay. Okay, it works. But what's more important than this working is the fact that the 1, 2 represents the coefficients of the other factor. So you know that 3 works and the 1, 2 gives you the other coefficients. So why is that important? Well, look, if we know we're getting 0 over 0, if we know we're getting 0 over 0 here, then here's what I can say about the synthetic division. I should get a 0 out if I use -2. That's what makes this factor down here 0. If I use -2 out here, and then let me put the coefficients. What are the coefficients of this polynomial up here? Be very careful. What are they?
Shouldn't it be -3 plus 0 minus 2 minus 20?
It's
0,
It'd be a
2 minus 20. So the -3 is in front of the x cubed. I don't have an x squared term, which is why I have a 0 here. And then I have a 2 in front of the x and then a -20 here. If we do this, what's that question or no?
Oh, no, I messed up and had a negative written. I had been had working it all wrong this whole time, no matter what.
Bring this down. This is -3. Multiply those two together, put it here at 6. Add down, we get 6. Multiply those two together, -12, put it here. Add down, you get -10. Multiply -2 and -10, you get 20. And voila, we get the 0, don't we? But again, that's not the important thing. The important thing is what this gives us, -3, 6, and -10. Those are the coefficients of the other factor, which means that I can write the polynomial -3x squared plus 6x minus 10. If I put that in parentheses and use this to create the other factor, then essentially what I've done is factor the polynomial. And if you don't believe this, multiply this out. And if you multiply this out, I promise you, you're going to get the numerator. Now, I kind of threw you right into the frying pan here, didn't I? Maybe I should have waited.
Does the fire come next?
No, I'll take you back out and I'll put you in the fridge after this, just to kind of get you back down to earth. I don't want you to get too freaked out by this algebra at this point.
Charlotte, quick question.
Yes.
That -2, that was a x plus 2, and that's because we just set that x equal to 0, right?
That's right. So the -2 comes from when you do synthetic division, you don't use the number that's here. You use the number that would make this 0, which would be -2. If this had been x minus 2, I would use plus 2.
Right,
Now
thanks.
these cancel, and we can take this limit now. So now we have no more division by 0. So we can go ahead and just figure out what happens when we plug -2 in here. So -2 squared is 4, times -3 is -12. 6 times -2 is -12, and then minus 10. So -34, yeah, -34 is the slope of the tangent line at that point. So now let's get the equation of the tangent line. Using this good old formula. We have the slope, don't we? The slope is -34. Do we have a point on this curve? The point that we're talking about? What is it?
Yeah, it's -220.
-220. So now I just plug in y minus 20 equals -34, x minus -2. I'm just going to solve for y. Uh, 68 minus 68. Distributing. Add 20 to both sides. There it is. Now, I'm going to need to check this visually. I'm going to go and graph this line now, and it better hit through that point. It better look like it's tangent to the curve. So it was y equals -34 x minus 48.
Yeah.
There it is. I don't know. It looks pretty good to me. Kind of hard to see it, but looks good. Okay. Now, I know that this is somewhat discouraging because this algebra, all right? So I'm going to show you something right now. You're not allowed to use this yet, but I want to show you where we're headed. Because obviously this is a real pain in the ass, isn't it? Like you can imagine how this could become very, very complicated, right?
Yeah.
If you can't factor.
Yeah.
So I'm just going to show this to you. We will go through this again later. You're not allowed to use this yet. I just want to show you this. Don't ask why, all right? Don't ask me why. I'll explain that later. I'm going to rewrite the original function. Here it is. I put the power here, the 3, and then because there's not a power here, I want everyone to realize there's a 1 here on the x, right? Okay, I'm going to do something. Again, don't ask why, just I'm going to do it. I'm going to take this 3, I'm going to bring it down in front and multiply times that -3. Okay, so what's 3 times -3?
-9.
-9.
27?
Right?
Negative 27 or something?
3, I'm multiplying, not 3
Oh.
raised to 3, I'm multiplying. -3 times 3, -9, right? X, and now instead of 3, I want you to subtract 1 from that power. So instead of 3, it's going to become 2. Okay, with me? Okay, do it on the other one, same thing. Bring the 1 out, multiply times the 2, what do you get?
Just
2 times 1?
Just
2.
3, wouldn't it?
Multiply.
No, yeah, it's just 2. Just 2.
Multiply. Okay, so bring that 2 and then X, now subtract 1 from the power.
Yeah.
Just
0.
0. Now anything raised to the 0 is 1. Okay. Now that is really weird what we just did, right? You've never seen anything like that before, right? When have we ever done anything like that? But check this out. I want us to now take the -2. Remember A was -2? I want you to plug -2 into this. Just plug -2 in. Let's see what we get. What is it?
-34.
That look familiar?
See, this is the way I was taught to do derivatives a long time ago. I was never taught the synthetic division way. It's weird.
Well, no, you were probably not taught the limit. So what we just did right now is we used a shortcut rule for doing the same thing we just did with the limit. Everything we did in the previous problem with that limit, all of this, doing the factoring, all of that, we came up with -34. By you just taking the power, bringing it out and doing that and that, like that, we got the same answer. It's not a coincidence. It will always work that way. And this is a shortcut, all right? And there's a bunch of shortcuts for doing these things. But before you get the shortcuts, you've got to suffer through the limits, all right? It's just like a rite of passage almost through calculus, all right? Everybody's got to suffer through the limits for a while. And then at some point, we hand you the shortcuts and you're like, thank you, thank you. And then we say, well, now that we give you the shortcuts, now we're going to make the functions harder. So it's kind of like a be careful what you wish for type thing, but it's all good. All right. We've got 10 minutes. I wanted to do another example, but I also wanted to leave a little bit of time to talk about the test if y'all wanted to talk about it. I have not written the test. Don't ask me how long it is, how many questions. I haven't even written it yet. So
Gonna make it manually?
Pardon?
So you're gonna just come up with all the questions in between now and Thursday?
Mm-hmm.
That's awesome.
Yeah.
Yeah, that's crazy.
I might actually just do it on Thursday in between on my office hours or something.
Do tomorrow, am I right?
Yeah, I can do it tomorrow. I might do it tonight. How about we do this? How about I offer you a bonus question to be turned in with your exam work? All right. So this means when you turn in your exam work on Thursday, include this problem as the last page, and that will be a bonus on the test. All right. I'm not giving you this problem because it's exceptionally hard or anything like that. If you follow what we were doing today, and you can recall the things we've done in the past, you have everything at your disposal to do this problem, all right? You've seen everything just in different forms. So here's what I want you to do as a bonus. Same two questions. Same two questions. Find the slope of the tangent line to a function at a specific point, and then find the equation of the tangent line. Here's the function though. So once you apply the formula, right, the slope of the tangent line is this very special limit. Once you plug everything in, you're just back to a limit. So what have you learned about limits? How do you attack limits? You know, see how you do with it. I would not want you to go to a tutor for this. I mean, I can't stop you, but I would prefer, if anything, you work with your classmates and each other, as opposed to going and finding someone, you know, that will just show you how to do it. I'd rather two or three of you, you know, talk and say, yeah, that's what I'm getting. You know, I don't mind you discussing it amongst each other. But if you're discussing it outside of that, I would consider that to be cheating on this, even though I can't really prove that you did it. Okay, visually, because I love visualization, what we're doing is we're taking this function. Was it x plus 1? Was it x plus 1? Yeah.
Yeah.
Yes.
Yeah, and we're looking at the value of 3 right here. Well, I'm not even going to tell you, but right here, this value right there. And we're trying to come up with the equation of that tangent line that goes across right there. You're going to first find the slope of it, and then you're going to find the equation of it. All right. We'll call it a day. We have a lot more to do here. Okay, there's plenty. So I would not start the homework for 2-1. Well, you could try numbers 3 through 6 if you wanted to. 2.1, 3 through 6, that if you wanted to kind of, you know, get going on it, I wouldn't want you to go any further than this because you might get yourself into some trouble. So 3, 4, 5, 6, those problems I think are within grasp. We've covered what we need to cover. It just, for those problems, it just says find the equation of the tangent line to the curve at a given point. They give you the point. Okay. We've got 6 minutes, so I'm happy to answer any questions, or you're free to go.
Yes, sir, I have a question.
Yes.
Can you post these notes in last class period notes as well?
Did I not do last class?
No, sir.
I've been real good about it. In fact, I built a macro into my mouse that should do it all in one step. Hold on, let me see if I can remember.
Yo, that's baller.
Let me see if it, I can't remember which button it is. Hold on. I probably could have done it by now, just manually, but. Oh, which button? Multi-key macro, which one is this bottom one? Let me try it. So when I'm in here, I hit this button, boom. I just need to name it. It's named, it's not in the right folder. That's the only thing.
That's really cool.
There it is. And then I can do this one. Boom, there it goes. Same place, there it is. Okay, so now I still need to upload them, but I will do that.
And can we, can I get some outside sources to work on some problems for the exam?
Can you do what?
get some outside problems to work on for the exam. We don't have, well, I don't have any for the textbook.
You don't have any,
Problems to work on for the exam.
yeah,
Like practice problems,
I need some
anything,
more
because the
practice
review was really short.
the review is short. Well, yeah, what I would do is take the review and just, have you worked all the problems in the homework?
Yes, sir.
Yeah. Have you looked online for other, like, remember when we looked at those worksheets and stuff? Have you looked at any of that?
Yeah, the thing is, those problems are not nowhere near what your problems are.
What's that?
Those problems are not nowhere, they're not close to what you gave us on a review. They're different, they're totally different.
Yeah. Well, here's my hesitation, and please take this the right way, okay? Please take this the right way. It's for everyone. I think what you're asking for is a lot. I'm just thinking about my experience in college. If I had a class where my professor had, posted videos, homework solution videos, gave me a review, all of those resources had, if I were to go ask them for more, I think they would have just told me, yeah, right. So it's not that I don't mind giving you more problems, but I don't think that's really kind of, the bar in your mind shouldn't be that the professor is going to go and do that for you. Like, you know what I'm saying? Like, not me personally, I don't mind doing it, but then I just don't want to set an expectation